All right, welcome back. We're continuing on with question number 3 in the 2012 Cimc math competition. Okay, we've done questions 1 and 2 in part A, and now we're moving on to question number 3. We're still in part A though, so we still just want that final answer. Okay, so let's jump in and we'll take a look at the question. So the length of a rectangle is 3 times its width. If the length is decreased by 5 and the width is increased by 5, the rectangle becomes a square. Determine the length of the original rectangle. Now, immediately upon seeing a question like this, when it says the length of a rectangle is 3 times its width, I would immediately draw a rectangle and label its length and width as such. Knowing that there's that relationship between the length and the width, that gives us an equation that we're probably going to use at some point. Okay? So the length, 3 times the width, and then we get more information. If the length is decreased by 5 and the width increased by 5, the rectangle becomes a square. So we're going to get 2 pictures here. Okay. So let's draw our first rectangle. Doesn't have to be to scale, it's just our picture. So here's our rectangle. And we have a width and we have a length. But we're given more information than just that. We know that the length is 3 times the width. So we're going to use that and we're going to combine it with some more information, and hopefully we'll be able to figure out the dimensions of the rectangle. Okay? Now, if we were to, let's redraw our rectangle here. If we were to decrease the length by 5 and increase the width by 5, we'd get ourselves a square. So little 5s here, we've decreased by 5, we've increased by 5, okay? And we would get a little square here. All right. So what does that tell us? Here. So we can get a little square if we take the length minus 5 and the width plus 5. We get ourselves a little square. Okay? Now what we want to do is we want to combine information here. We have L equals 3W. Length is 3 times the width. That's an equation we have from the first one. What we want to do is get another equation with our new information and substitute it in and try and solve for portions of the proportions of the rectangle. Okay? But all we know is that if we decrease the length by 5 and increase the width by 5, we get a square. That doesn't give us a relationship. Or does it? Squares are very special in that all the side lengths are the same. They're the same length. So knowing that this is a square gives us our final equation that we'll need. L minus 5 is equal to W plus 5. Okay? So let's go back to the original question and see what it is we're going to try and solve for. Determine the length of the original rectangle. What we'll do is we'll find the width and the length likely by solving these 2 equations, but specifically what we're looking for is the length of the original rectangle. Alright. So substitute these 2 equations into each other. What I want to do is either take this one over here, substitute it in for the length over here, or maybe I just want to get the width. Okay. So how about we take our first equation, which we'll label 1, and we'll sub him into 2. Oop. So we'll sub equation 1 into equation 2. So this length here, we can substitute that for 3W. 3W minus 5 is equal to W plus 5. Alright, so I want to collect all my W's on one side and all my numbers on the other side. So I can turn this into 3W minus W. I can bring this W over to this side. And this minus 5, I can bring him over to the right side with a plus. Five plus 5. So this simplifies to 2W equals 10. So I want to figure out what W is. Well, I'm going to isolate for W by dividing both sides by 2. Okay. So now I know that W is 10 divided by 2, or W is 5. So the width of the original rectangle is 5. Okay? But we're asked to determine the length of the original rectangle. The length. Determine the length of the original rectangle. All we have is the width, but we know right over here that the length is 3 times the width. Okay? So we can put this back in equation 1, and we know the length is 3 times the width, which is 3 times 5. We just learned that, which is 15. Okay? And we could make some statement somewhere. Let's put it over here. The length of the original, or I'm going to write first, is 15. Okay? We used both pieces of information, the original relationship, the length, and the related to the width, and we also used the information from the square, and that the two side lengths are equal. We got 2 equations we were able to solve, so we had 2 equations, 2 unknowns. We were able to work them out. It turned out that the length here was going to be equal to the 15. Okay? If we'd been asked to go a step further and figure out proportions, so the side length of the square perhaps, or the area of the square, we would have been able to do that. We were able to isolate W and then L, and that gave us all the information we could have in this question. Okay? So it's part A question. We would just simply write down 15, but now we've got equations, we've got reasoning, we've got part marks if we screwed up some of our arithmetic. All right? So thank you all, and hopefully you'll join me for question number 4.